Hello, my name is George Huber. I am the Richard Antoine Professor of Chemical Engineering at the University of Wisconsin-Madison and the Director of the Center for Upcycling of Waste Plastics, or CUWP. The objective of CUWP is to develop innovative technology that allows us to better recycle waste plastics using the power of chemistry and chemical engineering. Plastics are the most commonly used materials today. Plastics are very diverse in their chemical structure and used in almost every product we consume. This includes plastic soda bottles, milk jugs, food packaging, piping and construction, packaging, blister bags for medicine, mattresses and cushioning, clothing, and automobiles. Plastics are produced from crude oil and natural gas. In the US, we consume more than 37 million tons of plastics per year, which works out to be 740 pounds of plastics per person per year. In the US, more than 104 million tons of greenhouse gases are emitted during the plastic production process. While many people assume you can simply melt plastic down and reuse it, similar to the way aluminum cans are recycled, the process is much more complex. Not only are there dozens of different types of plastics, there are thousands of formulations and additives which make plastic recycling complicated. Because of that, today, only 2% of plastics are recycled in applications where virgin or chemically pure plastics can be used. The majority of plastics, over 40%, are sent to landfill where they can take thousands of years to degrade. 1/3 of plastics leak into the environment and end up in the ocean. It has been estimated that by 2040, there will be more plastics in the ocean than fish. 14% of plastics are burned to produce electricity, generating more greenhouse gas emissions. Another 14% of plastics are recycled in some form, where 4% of plastics are lost in the recycling process, 8% of plastics are recycled into lower quality material or downcycled, and only 2% is recycled into the material where the original plastics are used. Unfortunately, the recycling process today are inefficient and primarily only recycle number 1 and 2 rigid plastic material. These are plastics used in milk jugs and plastic bottles. Flexible packages, like those used in plastic bags, are not typically recycled. Some organizations do recycle them into lower quality material like asphalt or building materials through a process we call downcycling. The other types of plastics labeled 3 to 7 are not currently recyclable and are sent to landfill. This includes plastic bags, bottle caps, yogurt containers, styrofoam, mattresses, and a lot of food packaging. We clearly need better technology for plastic recycling. The first step in recycling of plastics is the MRF, or Material Recovery Facility. In the MRF, plastic, cardboard, and glass are sorted through a series of long conveyor belts. The number 1 and 2 plastics are then baled and sold to secondary recyclers who convert these materials into plastic pellets. Unfortunately, 30 to 60% of the plastics that are sent into MRF cannot be recycled and are sent to landfill. To help develop new technology for plastic recycling, we have created the Center for Upcycling of Waste Plastics, or CUWP. We have received $12.5 million in funding to create CUWP, primarily from the U.S. Department of Energy. Our center is headquartered at the University of Wisconsin and involves 6 other universities, including 2 in Mexico and 1 university in Canada. We are also involved with the National Renewable Energy Laboratory and the Plastics Industry Association. We have 8 companies who are members of our center that are involved in all aspects of the plastic value chain. These industrial partners are working close with the academic partners to create innovative plastic recycling technology. Within our center, we are studying how to thermally convert waste plastics into a plastic oil by a technology called pyrolysis. I am showing here a schematic of a reactor in my laboratory that can convert waste plastics into a liquid oil. The heating of the plastics is done at high temperature without oxygen, so the plastic is converted into a liquid rather than burned. We carefully control the reaction conditions to maximize the yield and the quality of the oil. That oil can then be used to produce fuels or even chemically separated into virgin polymers, which could be used to produce new plastic products. We hope that it will eventually be possible to do this on a very large scale. This is a picture of a factory or chemical plant that produces the most common plastic called polyethylene. This process is called steam cracking. The input to this factory is natural gas and the output is polyethylene pellets. This plant was built in 2017 and cost more than $6 billion to build. It produces 2 million tons of polyethylene per year, about 10% of the polyethylene that is produced in the US today. CUWP research could enable this factory to be able to use the plastic oil produced from the thermal decomposition of the plastics as a feedstock. This would then allow this plant to produce polyethylene from plastic waste in a closed-loop recycling process, similar to the way metals and glass are recycled over and over and over again. It also allows us to use the infrastructure that already exists and could eventually lead to similar plastic recycling facilities across the country and the world. CUWP researchers are also working with a company in Neenah, Wisconsin called Amcor. Amcor is the world's largest manufacturer of multilayer films used for food packaging. Amcor purchases different polymers and then converts them into multilayer plastic films. Most of the food you purchase at the grocery store is in these multilayer films, which improves the shelf life and maintains the quality of the food. Unfortunately, the Amcor facility also generates large amounts of waste plastic that can't be recycled and are currently sent to landfill. CUWP has developed a chemical technology called STRAP, which uses solvents to selectively dissolve individual plastics from the multilayer film. The process can take these multilayer films and convert them into the pure plastics that can be easily recycled by Amcor. This process could thus divert millions of tons of waste plastics from the landfill. CUWP is revolutionizing the plastic recycling industry by developing the scientific and engineering principles that will enable the circular upcycling of plastic waste into virgin plastic resins using chemical technology. We hope to continue to help aid Wisconsin industry, create Wisconsin jobs, improve the environment, and make Wisconsin a leader in plastic recycling by using our knowledge of chemistry and chemical engineering. Thank you for your time today.